Okay, let's get started. Oh, it's 1 o'clock. Welcome everybody to our next HDF clinic. Let's see. Let's pause here. And I had a homework assignment. I'm a bad student. I didn't do it. But before we talk about that, are there any questions? I checked our Google Doc. I didn't see any questions there. Are there any questions at this point?
Gerd, this is Robert. I just had one question. I didn't know if you were going to cover it today. And this regarded the post that the user had on, it was a failure to write when HDF5 hit a full file system.
Oh, yes, we come to that today.
Oh, okay. All right. Because it looked like it was converging nicely on a resolution toward the end. And it seemed to imply that maybe it was just a Windows dependency. And I wanted to, but if you're going to cover it, then
we will come to that. Yes. And the short answer is yes. At the moment, the story isn't over yet. But at the moment, it appears that it's a Windows only issue. But we'll talk about it. Yeah.
Okay.
Great,
okay. Thanks.
Great question. Yeah. And yeah, that's where we left off last time because we ran out of time to talk about it in any detail. And yeah, so I promised to come back to it today.
Okay. Well, the resolution looked promising, so I wanted to ask.
Okay, great. Okay, so yeah, my homework is there was this question. Okay, with HyperSlab selection, we talked about it. That the library just iterates over it in sort of grid point order, let's call it that. And but then the question was, well, what about point selections? And I promised to write an example and just check it out. And I haven't done it. I just haven't had any time. But I'll get back to it and report back. Okay, last week's highlights. We closed the registration for in-person attendance to this event, and it's a good turnout. I can tell you that for in-person and also remote. The registration remains open, however, for online. So if you just want to call in and participate, by all means, please continue to register. And the registration site and everything hasn't changed. Obviously, the date hasn't changed. And we look forward to meeting everybody in about 2 weeks. Well, yeah, actually, it's going to be exactly in 2 weeks because today is Tuesday. It's just going to be 7 hours ahead. But yeah, May 31st, that's in 2 weeks. News, we just released HDFView 3.2.0, and I just sort of peeked at the release notes. There were a few interesting things. There are other interesting features and bug fixes and whatnot, but the things that stood out to me were, number one, the swimmer support, which is an interesting thing, where I'm sure a lot of swimmer users would have asked, well, what's the deal, or sort of when will HDFView support swimmer? That's there now, and at least according to the release notes, there is now a configurable refresh timer that you can set, where HDFView, if you just have it open, will periodically check for any updates on the file. And so that, combined with swimmer, I think should give that a whole new experience. Then I read that the display and the editing of attribute data can now be in a table-like view, the same way it used to be with datasets. And also, I think Alan did some work for the command line tools already, but that's now also rolled into into HDFView, that if you are using non-standard, meaning non-IEEE, non-VAX, and sort of the traditional floating point numbers, like modern GPU-based floating point numbers, reduced precision and whatnot, that they can be read and displayed properly in HDFView. So there are other new things, but those were the ones that stood out to me.
Question.
Go ahead. Mm-hmm.
Does it mean that they are now supported in the library, or how well it is supported? Because
Mm-hmm. Well, I think they are supported in the library in the following sense that when HDFView and in turn the library opens, let's say, a data set of a custom, a non-standard, as we call it here, floating point number data type, that means that from the metadata that's present for that floating point data, we know sort of what is the precision of this type, what padding is there, what's the mantissa length, what's the exponent length, what's the bias, and so forth. And based on that, you can certainly come up with a string representation of the decimals and the exponent and whatnot of these floating point numbers. So I think that's what's meant by this. Does that make sense?
It makes sense, but I am interested in how it is tested. And the first testing case will be probably create from 128-bit of number from Python, from H5 and see what will happen. Yeah, it's great. No, it's great. But yeah, I have my reservations.
Okay, sure. Let's try it and report a bug.
Yeah.
You know the drill.
Right.
Okay. The other interesting thing is, over the last 2 weeks, we had the ECP event going on, the workshop, the baths, and so forth. And at this, as part of this event, several of the HDF group attendees presented this vol status report that I linked here. And I remember a few of these clinics ago, Martha was asking about DEOS recommendations and so forth. And while, of course, that's not the topic of this report, there are performance numbers included for different vol connectors and the differences in performance that were obtained, and so I think, and in particular, there are a few DEOS numbers included as well. And so I think for anybody interested in vols, but also DEOS and sort of other storage arrangements rather than sort of traditional parallel file systems, I think this is a must read, and there's a lot of interesting information here. Go ahead.
A quick question. Mohammed, that was very interesting presentation at DEOS above, where they introduced, DEOS team introduced new features, new objects that DEOS supports. Are there any plans to update DEOS vol connector? Because it may really help with performance. There is some like multiple keys object now, and there was something else, multi-dimensional array, I believe, that they natively support. I'm just curious if there are any plans to have DEOS vol 2.0.
Excellent question. I do not know the answer, but I will make a note here and report back. So you are saying, yeah, there are DEOS updates, and then question is, will there be DEOS, let's say version 2 vol? And yeah, I'll try to find out and report back. Yeah. Okay, great. And then yes, and this just came out, I think, yesterday. HSDS data streaming arrives. John has a nice little write-up of that, and I linked it here to the GitHub commit that he made for a test. And so the background of this is, you might say, well, data streaming in what sense? Well, what's meant by this is in HSDS, when you make a request, there is currently, or in the before this fix, there was a 100 megabyte cap on how much data would be returned or could be submitted to be read or written. And this 100 megabyte wasn't fixed, it was configurable. You could set it to 200 or even a gigabyte if you wanted to. But there was the parameter to control this in the HSDS configuration was this max request size. But the problem would be that no matter how big you set that, in the end, it would come down to that the server would have to reserve large quantities of RAM, depending on if you run this in a Docker container or Kubernetes pod. If there wasn't enough RAM there, you could set this to as big as you want. It just wouldn't have happened. And you would have gotten this sort of dreaded 413 payload too large error. And so the question is, well, what could be done or how to resolve this for good? And the idea that John and others developed was, well, what about if we did some streaming, in the sense that if it turns out that response is too large to be assembled on the HSDS server side, then let's just sort of page it or break it up into, you could almost say chunks, although those chunks would be different from the chunks in the HDF5 sense. And so let's start returning data, streaming, if you wish, incrementally to the client, for example, while we are sort of processing this whole request. And that's what's meant by streaming here. And it turns out, yeah, it works. You will not see this error anymore. Of course, if your client was asking for more data that it can handle, well, that's the client's problem, unfortunately. But at least it is no longer an issue on the HSDS on the server side. Okay, so that's and I'm sure there will be an announcement and maybe a blog post related to that. But that's I think a great improvement that was made. Okay, before switching to the forum, any questions up to this point? No? Okay, then we'll just continue. So yeah, basically, we want to pick up on a few things that we either didn't finish last time or where there are some new developments. One of the posts where there was some new development was one user was reporting, he was basically comparing direct chunk writes with the same type of write pattern, but to a contiguous data set. And he said, well, I think the figure that he quoted originally was like 50% slower. And he couldn't understand it, and we couldn't understand it either. And just to be sure, we provided a little test program, which I have linked here. It's just a simple C program that mimics his workload, just to rule out that there isn't any intermediate distortion of these results. And so if we go straight down to the C level, then we sort of see it up close. And so he was so kind to run this. And he, if you go to the forum and look at that thread, he reported these numbers, and I'll explain the headings here in a moment. And he timed it with just the standard Linux clock get time functions. And here's what he obtained. So let me explain the column names first. So these are the timings for direct chunk, meaning where he uses H5D write chunk. And so he basically, remember, that was the situation where, think of a three-dimensional data set where time or sequence is the slowest changing dimension. And then in each write step, we are writing a 2D image or a frame, so to speak. And we just do that frame by frame by frame. And for each of these, and this is actually also a chunk size. So a frame size, a chunk size is 1 times number of, if you want to call it, image width times image height. So that's we are writing a full chunk every time. And in this direct chunk situation, we do that with H5D write chunk. In hyperslab chunk, what we do is we have the same chunked data set. However, rather than using H5D write chunk, we are just using H5D write. And yes, we would have to make a hyperslab selection and then go through the H5D write pipeline. And here are the results, which I'll comment on the row labeling in a moment. And last but not least, writing the same pattern. However, let's assume in the application we know a priori how many time steps or sequence steps we will have to write. And then we can just allocate this three-dimensional data set in one shot and then basically make hyperslab selections and use H5D write, however, against a contiguously laid out data set. And so those are the meanings of the columns. And then for the rows, now we can start playing with data set creation properties, such as just using what he calls here regular, is just using all the defaults. And that means different things for chunk data sets and contiguous data sets. So for example, the default for a chunked data set, it would mean that on the first write, that chunk gets physically allocated in the file, and fill values actually get written to that chunk. That's what that means. In the case of a contiguous data set, it means that, also that the data set, that the complete three-dimensional, the space in the file that corresponds to this three-dimensional array will be allocated on the first write, and then never changes because it's contiguous, and so the dimensions cannot change. There is of course a difference between direct chunk and hyperslab chunk, because in the case of direct chunk, there is no discussion about fill values or not, or allocation time or not. When you call H5D write chunk, the library reserves space for that chunk in the file and just takes your bytes and puts them right there. There's no question about fill values or initializing something. It just takes your bytes and puts them there. Never fill means that in the case of sort of not using H5D write chunk, when that chunk gets allocated, to tell the library, well, just don't bother initializing those just allocated chunks with fill values. And we'll see in a moment that that plays a role. Latest format, as many of you know, that there were improvements made to the file format over time, and you can, as a file access property list, instruct the library to use the latest file format. However, since this is a relatively straightforward use case, there's really nothing of the improvements that were made to the file format over time that in this case would make any difference. So we wouldn't expect any surprises here. And then, of course, you can combine some of these. So let's quickly go through this. First, we wouldn't expect any of these to have any impact on when you call H5D write chunk. It's basically like calling pwrite and say, here's some data, put it in a file. And so there is a little bit of fluctuation here, but it's just noise. So consistent performer here, no surprises. That's what we want to see. Hyperslab chunk, again, instead of calling H5D write chunk, we are calling H5D write. And that is sensitive to, number one, whether fill values actually get written to a chunk that was just allocated. And we see, it's basically calling write twice. And so if we use the default property lists for everything, then we see double the time roughly for compared to the case when we instruct the library to not bother initializing that just allocated chunk with fill values. But then if you compare it, for example, with a direct write, the there is actually, the chunks are actually relatively large in this case. If I remember correctly, they are on the order of 4 to 8, maybe 6 megabytes or something like that. So they are not tiny, they're good size. So yes, there is overhead due to the library has to check, okay, are there any data conversions? Are there any selections? Are there any this and that? But this is really compared to the time that it takes to put down that chunk into the file, there's not a huge difference between the two. Likewise, again, this is just using the defaults, but with the latest file format. So we still do 2 writes per chunk, and so this is consistent with this case. And so we can understand, I think, completely how these results come about. No surprises here. The interesting thing is, seeing what essentially the user reported, which is that hyperslab contiguous, since everything, the allocation happens all at once, and also the writing of fill values. And I think in this case, there is something, the initialization with fill values actually happens only if set. There is one of the enumeration constants is if set, but since nothing is set in this case, it never happens. So it's the same allocation across the board. That's why these numbers are more or less all the same. However, what is puzzling is that compared to the direct chunk write, the performance is about 25% worse. Why is that? And the answer is, I don't know. I just don't know. And I'm a little surprised by it. And if you ask me to sort of make a suggestion or bet money on something, my hunch would be that as part of this contiguous writing process, since we are not just going straight to some kind of p-write, there is of course there will be buffering inside of the library taking place here. Any copy, for example, any additional copy of that buffer, you would notice that. So my hunch is, and I think our homework is to really carefully examine this write path and see if there is an extraneous or something that we can eliminate a copy going on here that, in large quantities, I forgot how many, I think he tested this with tens of thousands of time steps, would accumulate to sort of 25% slower performance. And but that's where that stands. So there was, I think he reported another figure where he showed that this overhead might be somehow sensitive to the number of time steps. Again, I don't believe that, or I would find that somewhat counterintuitive. So he hasn't given us that number yet. So the difference between writing 10 steps or 100 steps or 1,000 or 10,000 steps and so forth, he might report back on that. But maybe this was also something that he did something wrong when he produced that initial figure that you find in the forum post. But anyway, so there is a little bit of a detective work left here that needs to be done. But it was great that he produced these numbers for us, and it just shows it's when these things work, it's a give and take, and it's the user asks a question, and then we come together and we sort of agree that we are all looking at the same thing, and we try to make it as simple as possible, and then they run it with their parameters, and we look at some numbers, and then we can start thinking about what exactly is going on here. Okay, any questions about that?
Yes, quick question. So do I understand correctly, and maybe it's in this program, that each time, for example, each cell is just writing one chunk, essentially one place in the array using chunking, hyperslab chunk, or it is accumulating time? What is measured? A write of each chunk or a total?
This is here the total. There is if you look at the example program, there's basically a for loop that writes all these frames. And he said he put the timer around this for loop. So this measures the total time that it takes to go through that entire sequence of writes.
Because I think you will get different numbers if you put around each write, it will be different. But and the case. Okay.
Yeah, but it's cumulative in this case. Yeah. So we'll see, but it's a good first step. And yeah, if there is, it's for us definitely if we see that there is an redundant copy somewhere in this case, then yeah, let's see if we can fix that. Yeah. Okay. Moving on. So this is what Robert asked in the beginning. Now, I did not repeat the example. We had that in last week's clinic. So this is the example that we tried to use as a reproducer. And he worked on that. And so where that discussion stands is that then Dana took this example. This user was running this on Windows, and Dana tried to reproduce this on Linux. And what he basically did is he created sort of a RAM file system of just 8 megabytes, and tried to compiled and ran the test program. The test program basically tries to write in that location that turns out to be too small to produce this write error because of a disk full. And then we sort of back away from that and choose a different path and then try to write it again. And then it succeeds. And then we just close everything and the library is supposed to cleanly shut down. And so what Dana did is basically use a RAM disk to mimic this behavior under Linux. And he cannot reproduce this problem, which is that apparently under Windows, that when the library shuts down, there is an assertion failure, which basically indicates that the library somehow screws up its own accounting of which objects are still open and whatnot. And in this particular case, it's a file ID that the library believes is still in use, and the thing is open and it can't really shut it down. And so Dana could not reproduce this under Linux, and he actually asked people who read this or who are reading this if anybody under Linux or macOS could reproduce the issue. Nobody has reported anything so far, which is not to say that somebody, like right after this meeting, I might check the forum and somebody might have reported something, okay, but not over this previous week, which suggests a little bit that this might be a Windows-specific error, and maybe that's why we didn't really spot it early on, because yeah, it never appeared. So the library under Linux-like systems or Unix-like system, the code seems to be written so that the library is indeed able to recover gracefully and completely deal with that open file handle and close it and say, yes, there was a failed write, but that doesn't really screw up the bookkeeping and accounting. And so that's where that stands. And so we will keep following this. But then, of course, on the flip side, the interesting question would be, what is it under Windows that somehow causes this? And it could be something that, of course, our sec_root driver uses the sort of the POSIX emulation that is provided by the Windows C runtime. And maybe it's a function in there that somehow behaves slightly differently from how it behaves on Unix-like systems, and that's where this whole thing gets off the rails. And then if that's the case, then let's see what we can do to fix it, because yeah, we don't, I mean, that's the last thing that we want users under Windows when the library shuts down to sort of trip an assertion and then a little bit all hell breaks loose or something like that. That's not a good situation. And so this is still ongoing. Does that answer your question, Robert, to a degree?
Yes, yeah, that sounds good. But just to clarify, Gerd, on the Linux experiments, when in those cases when the user then goes to write it to an alternate store that does have sufficient space, the HDF5 file is correct at that point.
Yes.
on Linux, that part is taken care of. So it really does come down to tracking down what specifically is going on Windows. Yeah.
I mean, that first file that fails to be written completely, that's in an undefined state. There's nothing we can do about that because, as I said earlier, what is the correct state of that file is in a way not known. Because when that write fails, there could have been other content in memory that had not been flushed before that write failed. But now, okay, that write failed, but we cannot flush the stuff that's still out there in memory. So that whatever bytes are on disk there that belong to that file that could not be completed, that's totally undefined. So there's nothing that we can do about that file, no matter if it's Linux or Windows. It's just not possible to put that into a well-defined state because it's not clear what that well-defined state would be anyway. However, that second file where there is enough space and everything, yeah, that is just a clean and nice HDF5 file that has everything that belongs there.
Gerd, I will say that if you do use Swimmer to write and you use I'm out of space, Swimmer will guarantee that that file is consistent. It may not have all your data in it, but it will not be corrupted. It might just be, you know, everything up to here is complete.
Okay, that's a good data point. And but also, since I didn't know you were here, welcome. Can you think of something what maybe in the Windows POSIX emulation, so to speak, might be different here than to sort of throw the whole handle counting and so forth off track, so that later during shutdown under Linux everything seems to be clean and we just go home, and various under Windows, yeah, there's panic.
I'm uncertain. You know, it would really require some probing from the Windows side of it, and the emulation of POSIX on a Windows file system is going to be different than a truly POSIX file system. So not certain.
Okay.
It's probably just the OS level error reporting that's different.
Great. And then we are slightly over time already, but hey, let's end with a good story. Remember, there was this other issue where somebody reported that, yeah, they knew that during H5 Pi sort of premature shutdown, they had written some important data, but then they found out that the library really couldn't open the file anymore and command line tools weren't working and so forth. But the file was sizable, I think 220 megabytes or something like that. And there were some really, really important data in there. So we told the user that, yeah, there are some sort of file format description, documentation, plus other information. And if you are determined and everything, you can look around and see what you can recover. And the user, interestingly, also told us that, yeah, even if you cannot necessarily reproduce all the link names and everything, he knew that there were attributes on data sets corresponding to timestamps that he could actually, if he could recover that, he could then actually uniquely identify which data set is which. And it turns out we sent him links to the file format specification, Quincy to your file format tutorial, and a few other things, and he did it. And I think that's a great story. And it's a lost business opportunity for us for our forensic service, but it's a great story, and it just shows to, hey, if you're open source as far as the software goes and the specification, then that goes a long way. And
I'm
so
glad
I think
the spec was strong enough to support him going in there and doing that.
Yeah. So that's great. Maybe we can convince him. I'll try to contact him, see if he's willing to work with us on a blog post or something, because I want to know how the experience was, in the sense of how much blood, sweat, and tears, or otherwise it was really to dig all that. But obviously the data was important enough for him to really go through this effort. And and then for us, let's see what we can improve to make that even easier next time. Okay, we're out of time. Sorry. Thanks everybody for coming, and come back next week and enjoy the rest of your day.